In Chapter 7, we're exploring conic sections. And if you didn't know what conic sections are, it's cross-sections of a double-napped cone. Now, if you don't know what a double-napped cone looks like, it's two cones sitting on top of each other, point to point. Visually, this is what I'm referring to. Notice how these cones are vertex to vertex. So if I slice it horizontally, I get a circle. If I slice it at an angle, it's an ellipse. At a deeper angle, where it's only slicing through one side of one cone, then it's a parabola. If it's vertically, then it's slicing through both cones, and I get a hyperbola. So in this lesson, we're looking at parabolas. And you've seen parabolas before, and the parabola is formed by the set of all points in a plane that are equidistant from a given point called the focus and a given line called the directrix. We have already talked about the axis of symmetry of a parabola. We have already talked about the vertex of a parabola. And so here's a few details about a parabola, and the book likes to formulaize a lot of stuff. I don't like to think about things in terms of formulas, so that's why you'll see me sketch a parabola before I actually graph it on the grid. So let's begin. In example 1, part A, I'm identifying the vertex, focus, axis of symmetry, and directrix. Well, notice how here we can see that the vertex is right there staring at us. So the vertex is 4, 3. -3. Excuse me. So right away, let me point something out that might cause a bit of difficulty, as just now it did. We are very, very used to the number with the x being the opposite of what we see, but the number with the y being exactly what it is. Notice how up here, it's both x minus h and y minus k. Now, you can't see it very clearly on the screen, perhaps, but you do have it very clearly in your notes. All right, so it's always the opposite of what you see in the parenthesis. All right, so the vertex we have. Now, the focus and the focus and the directrix are both the same distance away from the vertex in opposite directions. Well, one way that I like to figure out where those two things are is to kind of get an idea of what this graph looks like. Since the x is being squared, I know that this is a vertical parabola, meaning it's going to open either up or down. And since this value is positive, that means it's opening up. So if I were to sketch this, it would kind of look like that. My focus is always inside of the parabola, and the directrix is always kind of outside of it. So right away, I know that my directrix is a horizontal line, meaning its equation is going to be y equals a number. Well, let's figure out how far away the focus and the directrix are from the vertex. That's given to us by this number. 8 equals 4p. And p is the distance from the vertex for the focus and the directrix. So that means p is 2. So that means that the focus is 2 spaces above the vertex. So above is a vertical distinction, so I'm looking at the y-coordinate, so I'm adding 2 to this y-coordinate for the focus, and I get 4, -1. Going in the opposite direction, my directrix, I already said, was going to have the equation y equals a number. It's going to be 2 spaces below this vertex at -5. It's also asking for the axis of symmetry. Remember that the axis of symmetry is a vertical line in this instance. It's going to be passing through the vertex. So vertical line means its equation is x equals a number, and it's going to equal the x-coordinate of my vertex. X equals 4. What else did it want? It wanted the vertex, found it, focus, found it, directrix and axis of symmetry, found it. Now it wants us to graph. Okay, at this point, there's really no nice, pretty way to do this other than kind of figuring out, we already know where the vertex is, and maybe plug in another value for x and go from there. All right, so if I plug in, I already know that if x equals 4, y will equal -3. That's my vertex. So I'm going to go ahead and plot that. 1, 2, 3, 4, -1, 2, 3. There's my vertex. And if I plug in a number for x and then solve for y, try to keep in mind that you're eventually going to be dividing by 8. So maybe plugging in something like 6 would be a good place to start. So I'm going to plug in 6 for x, and when I do, I have 6 minus 4, which is 2. 2 squared is 4, so 4 equals 8y plus 24. 8y is -20, so y is -2.5. So 6 comma -2.5 is here. Remember, this is our axis of symmetry. Think about that word symmetry. I can use that symmetry to get this other point. And so this is kind of a wide parabola. Part B, we do the same thing. Vertex is right here staring at us. The vertex is -6, -1. Notice this time that it's the y being squared, so this is a sideways parabola. This value is still positive, so it's going to be opening in a positive direction. That means it looks like this, where my focus is inside and my directrix is outside. I have to find the value of p. 2 equals 4p. If there's any confusion about where this 4p is coming from, notice that it's here. So that means that p equals 1/2. So that means that the focus is 1/2 a space to the right of the vertex. So my focus, 1/2 space to the right of -6 is -5.5. The directrix, notice how I sketched it as a vertical line. That means it's going to have the equation x equals a number that is 1/2 to the left of this -6. So that's -6.5. My axis of symmetry is going to be a horizontal line. So I know it's going to have the equation y equals a number that is the y coordinate of my vertex. So y equals -1 is my axis of symmetry. So again, the last thing that they're asking me to do is to graph. I already know that this passes through -6, -1. And so maybe I want to plug in maybe -4 for x. So when I plug in -4 for x, I have 2 times 2, which is 4. So 4 equals y plus 1 quantity squared. So that means y plus 1 has to equal positive or -2. And that means y equals If I have a positive 2, I subtract the 1, that means y equals 1. If this is negative 2 with another negative 1, then that's also negative 3. So negative 6 comma negative 1. Negative 4 comma positive 1 and also negative 3. So something like that. And so in this example, what we found or may have noticed here is that the process of plugging in for the variable that's being squared, like we did back here, we plugged in for x and x was being squared, that might be an easier route to go than plugging in for x always. Something to think about. In these examples, our equation is not given to us in standard form, so we have to figure out what it would look like in standard form. Something to notice. Notice how the x is being squared. So when I have my x in its parenthesis, there's going to be a squared outside of it. Now think about what happens when you square a binomial. If it's x plus a number other than 0, then there's an x term as well as an x squared term. Notice how in the equation there is no x term, which means the number in the parenthesis with the x therefore must be 0. I'm going to bring everything else over to the right-hand side and get 4y plus 4. Remember what standard form looks like. I want a number, and then I want the y either plus or minus a value. So I'm going to factor this 4 out. I have x minus 0, quantity squared, equals 4 times the quantity y plus 1. That means that my vertex is at 0, comma negative 1. Because 4 equals 4p, I know that p equals 1. Since my x is the variable that's being squared, I know this is opening vertically. Since p is positive, I know that it's opening positive vertically. So once again, it looks kind of like this. Not quite so ugly, but you get the idea. And the focus is above the vertex by 1 unit. So what's 1 unit above negative 1? 0. So that means my focus is at 0, comma 0. My directrix, remember, it's going to look like that. Since it's a horizontal line, I know it's y equals, and it is 1 space below my vertex. So it's at negative 2. My axis of symmetry, that's this vertical line passing through my vertex, so it has to have the x-coordinate of my vertex, x equals 0. And then we graph it. So once again, I know that this graph is passing through 0, comma negative 1, and maybe plugging in, I don't know, 2 for x might work out okay. So let's plug in 2 for x. When I plug in 2 for x here, I get 2 minus 0, which is 2. 2 squared is 4. So 4 equals 4y plus 4. So 4y equals 0. That means the graph passes through 2, comma 0. So let's plot these points and use symmetry to get a third point. My vertex is at 0, comma negative 1. I know it's passing through 2, comma 0, which is here. I know that my axis of symmetry is that y-axis. So that gives me this point also. Connect the dots. Similar idea in part B. I notice, first of all, what variable is being squared. Second of all, I notice that there is a y term, so I'm going to have to complete the square in order to figure out what number is inside the parenthesis with the y being squared. And then finally, third of all, I notice something fantastically convenient about all of the terms in my equation. They're all divisible by 3. And so to make my life easier, I'm going to divide this whole equation by 3 and get y squared plus 2y plus 5 equals 4x. And keep in mind, there is a reason why I want to do that. I mentioned earlier I'm going to have to complete the square. Completing the square is a whole lot easier when the variable being squared has a coefficient of 1. All right, so I've got my y stuff over here. I'm going to move the 5 over and get y squared plus 2y, and I'm going to leave a blank here and I'll explain it momentarily, equal to 4x minus 5. So in order to complete the square, I have to figure out the number that I have to add to this expression so that I can rewrite it as a binomial being squared. And we did this way back at the beginning of the year. Let me refresh your memory. You take this number, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. And whatever I do to one side of the equation, I better do to the other, which is really convenient on the right-hand side because now you'll notice that that 4 will factor out very nicely. So this I can now rewrite as y plus 1 quantity squared equal to 4 times the quantity. Notice how these two terms will combine to get negative 4, so that's why I can factor a 4 out and get x minus 1. So now my equation is in standard form, and I can easily identify my vertex and figure out the rest. So the vertex is at 1, negative 1. I have to find the value of p so I know how far away my vertex is from my parabola, from my focus and directrix. Also, I mentioned earlier it's the y being squared here, so I know it's opening horizontally. It's opening horizontally positively, so it kind of looks like this, which means my focus is to the right of my vertex. That's 4p. So if 4 equals 4p, then p equals 1, which means my focus is one space to the right of my vertex at 2, negative 1. My directrix, notice, is this vertical line. A vertical line has the equation x equals a number that is one space to the left of my vertex, which is 0. My axis of symmetry is going to be a horizontal line, so it's going to have the equation y equals a number, and since it passes through the vertex, it's the y-coordinate of the vertex, y equals negative 1. Lastly, we're going to graph this. As I said before, we may have noticed in the last example that plugging in for x isn't always the best idea. Maybe we want to plug in for y in this instance, since y is being squared. All right, so I know that my graph passes through 1, negative 1, and maybe I want to plug in, since I have this y value of negative 1 and I don't want to go too far away from it, I'm going to plug in negative 3 for y. So when I do, I'm kind of running out of space here, I'm going to do it down here. When I plug in negative 3 for y, I have negative 3 plus 1 is negative 2, squared is 4, equals 4, let me go ahead and distribute, 4x minus 4. So 4x equals 8, and x is 2. So we're going to use symmetry again to find a third point. Let's start with what we have already. 1, negative 1 is my vertex. 2, negative 3 is another point on my graph. This is my axis of symmetry, y equals negative 1. And so this point, I can reflect over it to get a third point on my graph and then connect the dots. And the last kind of example in our notes, the instructions say write an equation for and graph. We're only going to write the equation for it. And we're only going to deal with parts A and B. Right? So in part A, I know where the focus is. I know where the vertex is. Again, I don't like formulas, and I don't want you to drive yourself nuts trying to memorize formulas. I want you to conceptualize this. Visualize this vertex and focus. If you need to, sketch it. Okay, so if I have this vertex at negative 6, negative 1, it would be here. If my focus is negative 6, negative 2, that would make my focus up here, which means this graph is opening up. So it's an x term that's being squared. And let's figure out the value of p later. Okay, so x plus 6 squared equals, I'm going to leave a blank here for 4p. We'll figure out what 4p is momentarily. Times y plus 1. And then, like I said, we got to figure out the value of p. Well, p, remember, is the distance between the focus and the vertex. They are 3 spaces away. Look at their y coordinates. They're 3 spaces away. So remember that this number here is always 4 times p. 4 times 3 is 12. So there's my equation for part A. For part B, similar idea. Start by sketching it out. My vertex is at 9, negative 2, so that would be here. My focus is at 5, negative 2, which means this graph is going like that. So it's horizontally opening, which makes it a y squared graph. And also we know that the value of p is going to be negative. Okay, so that means y plus 2 squared equals, and we'll figure out this 4p value momentarily, x minus 9. Now we know it's negative because it's opening to the left. But again, how far away is the focus from the vertex? It's 4 spaces away. 4 times 4 is 16. So there's your equation.